In the previous video, we looked at calculating future value. If you haven't seen that video yet and you want to check it out, look at the link in the description below. Today's video will focus on the present value, which is the value right now or today of some amount of money in the future. If you don't quite understand this yet, don't worry, as it can be a bit challenging to wrap your head around this until working on some numerical problems. With that being said, let's get into the numerical problems. Today, you make a deposit in a savings account that pays 4% per year. Assume that in 5 years, you will need exactly $25,000 from this account to use as a down payment for a mortgage. What amount must you deposit today to have exactly $25,000 in 5 years? Assume no additional deposits or withdrawals are made. This is the present value formula that we will use to answer these types of questions. So the present value is equal to the future value. So the future value is the $25,000 because that's the amount we will need in the future, divided by 1 plus R, which is R is 4% in this case. We know that because the savings account pays 4% interest per year, and to the exponent T. So T is 5 years, it's the number of periods. This is what it looks like when we sub in that information into this formula. So as you can see here, we get the $25,000 future value divided by 1 plus 0.04, which is 4% to the exponent 5. When you solve that, it equals $20,548.18. So in other words, we can interpret this as we will need to deposit $20,548.18 today to have $25,000 in this account in 5 years. In the first part, we concluded that in order to have $25,000 in 5 years, we will need to invest $20,548.18 today in this savings account that pays 4% interest per year. In part 2, it states, assume that instead of needing the $25,000 in 5 years, you now need the $25,000 in 10 years. Pause the video for a second and try this question on your own and see what you get. To walk you through how we would solve this, this should be your thought process as you're going through the question. So we know that the numerator will stay constant because the amount we needed, or the future value, will stay constant at $25,000. So the numerator, or the future value, is going to be the $25,000. That's not changing. We also know that the R value will stay the same at 4% because it is the same savings account that we are using. What does change is this variable T. It was previously 5 because we needed the $25,000 in 5 years. We now need the $25,000 in 10 years. The answer you should have came up with is $16,889.10. So in other words, if we needed the $25,000 in 10 years, we would have to invest $16,889.10 today. One last thing I want to point out before we wrap up the video is that notice how the amount we needed to deposit when we needed $25,000 in 5 years is greater than the amount we needed to invest when we need the $25,000 in 10 years. Why do you think this is? The answer is, when we need the $25,000 in 5 years, the deposit has less time to compound. So that's why we have to, in order to make up for that less time, we have to invest a little bit more. So if we need the $25,000 in 3 years, let's say, we know that it would be higher than this $20,548 because we'd have to make up for those 2 years lost of compounding. So we know it would be higher than this $20,548.18.